Okay, so now we're going to be dealing with parallel and perpendicular lines. Now, parallel lines are lines which will never intercept because they have the same slope or gradient. Okay, so now let's have a go at showing you an example. So say we've got a dot here at -3, running up to 3 over here, -1 to 1. Now, I'll try and do a straight line. Okay, so you would remember from other lessons is that our gradient is rise over run. Okay, that's our gradient. So to look at this example, we can actually work out as well what our gradient would be. So let's look at, this is line number 2, this is line number 1. So if we start here to make our right angle, we can establish that between here and here our run is 2, and between here and here our rise is 2. So therefore line 2 tells us that their rise over run is 2 over 2. Similarly, if we go and look at line number 1, we can go from our 3 over to 2 because that's where this one starts, okay? This one right here, and then we can go up. Again, we can see that our run is 2 and our rise here is 2. So line 1 is also 2 over 2. So these lines are definitely parallel. They are never going to meet, and their gradient or their slope is always going to be the same. Okay, so now what we want to do is try and work out whether two lines are actually parallel mathematically. So let's use this couple of formulas or equations for lines. So we have 2y equals 4x take 9, and the other equation, let's say we have 3y take x plus 5 equals 0. So to work out whether these are parallel, we need to work out our gradient because the gradient needs to be the same. Alright, so just like before, we want to take this 2 and we want to bring it over to this side. So we're left with y equals, now we need to multiply because remember there's a multiply here, so we need to divide on this side. So 4 divided by 2 is 2x, take 9 divided by 2. So for our line 1, let's say we gradient 1, we're saying that our gradient is 2. Because, remember, as part of our, let me write it down here, y equals mx plus c. This part here is our gradient, which is the same up here. So we've worked out that our gradient for this one here is 2. Now let's move over to this side. Let's have a look. So again, we have -6, so we want to make it a +6. Take 5, because we want to take this over here, this over here. We're going to do the opposite. So the opposite of minus is a plus. Opposite of a plus is a minus. Okay. And that is equal to 3y. Then we want to change this to a y. We need, remember this is a multiplication. We need to divide it. So 6 divided by 3 is 2. 2x take 5 over 3. So for our second line, our gradient is 2. So these are definitely the same. So they are parallel. Beautiful. Okay, so now we're going to look at perpendicular lines. Now when we're thinking of perpendicular, we need to understand that in order to be perpendicular, that lines need to intersect at a right angle. Okay, so basically here, let's say we're intersecting. This here is our right angle. Now let's say we have an equation of y equals -2x plus 4. We know that that's for one line, okay, we'll call that number 1. Now we know that our y-intercept is 4. So we're going to come over here, and there's one line there, okay. We also know we have a gradient of 2, so we're going to come across 2, which is here, and that's our first line, okay. So this is line 1. For our other line 2, our equation is 1 over 2, remember, rise over run, x plus 2. I'll change colours. Okay, so now we're starting at, so our gradient here is 2, which is right here, okay, and the other line will be negative 4. Okay, so here's our line here. So this is y equals 1/2 x plus 2, and this line here is y equals negative 2x plus 4. So I know this is drawn roughly, but here is our right angle here. So because we've got that right angle, we know that this is perpendicular. Another way to realise whether it's perpendicular is, let me move this up a bit, move that up, is, okay, so another way, let's say, like these are called our lines, but let's say I've called it, this is M1 and M2 because M equals a gradient. So what we need to understand is when you multiply M1 by M2, you obtain a negative 1. Okay, so that is our rule. Let me move this up a little bit more again. Okay, therefore, using the our example up here, we had M1 M2 equals negative 2, which is this one here, multiplied by 1/2, which is here, equals negative 1. So that is our formula to make sure that our lines are actually perpendicular.